This section is 4.5, completing the square. So this is the vocabulary that you need to know for this section. It's square root property, completing the square, and our objectives are we're going to learn to solve quadratic equations by using the square root property, and we're going to solve quadratic equations by completing the square, which should be new to us. So let's first go back and review what is solving using square root property. Well, we're going to do that to this problem. What does it say? So first of all, let's just look at what we have here. Remember, we have a perfect square trinomial that we learned back in 4.1. And to factor that, it's just the square root of the quadratic term, this sign, and the square root of the constant term. And the whole thing is squared, equals 36. Now the square root property says we can solve this by taking the square root of both sides. When we take the square root of this, it's simply x plus 3 equals plus or minus 6. Now we can solve for x by subtracting 3 from both sides, subtracting 3, and we get x equals 3 plus or minus 6, which we can say x is equal to 3 plus 6, or x equals to 3 minus 6. And we would get 9 and negative 3 as our solution for this particular one. Now, remember, roots that are irrational numbers may be written as exact or radical form as approximate answers in decimal form when we use a calculator. For instance, if we looked on example 2 on page 257 and we solve that, and we're not going to, we're just going to look at the solutions. The solutions are x equal 5 plus 3 square root of 3, or 5 minus 3 square root of 3. So we have an irrational number because of the square root. So we can leave it like this as an exact answer, or we can punch it in our calculator and get an approximate value, and this would be 10.2 or negative 0.2. Either one of them will work. All right, so that's a review of square root property. That was one way of doing it. The second way is completing the square, which is a whole new process to you. So all quadratic equations can be solved using the square root property by manipulating the equation until one side is a perfect square. This method is called completing the square. So let's consider this equation. X squared plus 16x equal 9. So it's already done for us where the quadratic term and the linear term on one side by itself of the equation, and the constant term is on the other side. Once we do that, in order to complete the square, remember, if we put this in standard form, we would say A is 1, B is 16, and C equals negative 9. Well, all we care about is B. It's 16. So to complete the square, you take B over 2 and you square it. So if we take B over 2, we're going to get 16 over 2, and we're going to square it. So we have to do inside first. We have 8 squared, which equals 64. So we're going to add 64 to the left side. Remember, the additive property or addition property of the equation says what you add to one side, you must add to the other side to balance the equation out, or you've now changed the value of this equation. So when we add this, we get 73 on the right. And then now, by completing the square, we've now made this into a perfect square trinomial. So to factor that, you take the square root of the quadratic term, this sign, which is plus, and the square root of the constant term, which is 8. And then now we have squared. So now we can use the square root theorem. It says if I take the square root of both sides, I get x plus 8 equals plus or minus the square root of 73. And then I minus 8 from both sides. So I have x equal negative 8 plus or minus square root of 73. Now this says plus or minus. So the objective of this is to take your quadratic equation, put the quadratic term and the linear term on one side, take the constant term, put on the other side of the equation using algebra. Then we simply use this formula, b divided by 2 square, and we add that to both sides. We've now made a perfect square trinomial. We can factor it, and then we can use the square root theorem by taking the square root of both sides. And that's simply your answer. So now, when the coefficient of the quadratic term is not 1, you must divide the equation that the coefficient before completing the square. So let's look at that. That's the only one exception we have to do. So let's look at this one. It's 2x squared minus 7x plus 5 equals 0. So the first thing we do, we're going to move this over to the left side. 2x squared minus 7x equals negative 5. Then we've got to make this 1. In order to do that, I have to divide that by 2, and I'm using the division property or multiplicative property of equations. It says I must do it to every term of the equation. So now I get x squared minus 7 half x equal negative 5 halves. So now I'm going to take b, which is negative 7 over 2. I'm going to divide by 2, or it's the same thing as multiplying by its reciprocal and squaring it, so I get negative 7 over 4, and I'm going to square that, and I get 49 over 16. So I'm going to add 49 over 16. Remember, that's b over 2 square, and I'm just using complex fractions here. So we have to add it to this side. So then we take the square root of this, we take this sign, this is going to be 7 over 4, and we're going to square it. Now to add fractions, we must have a common denominator. So this is going to be 8, this is going to be 40. So negative 40 16 plus 49 16 is simply 9 over 16. Now if I want to I use the square root theorem and take the square root of both sides. X minus 7/4 equals plus or minus 3/4. And then I add 7/4 to both sides, so I have x equals 7/4 plus 3/4, and x equals 7/4 minus 3/4, and my solutions is 4 over 4, or 1, and 10 over 4, which is simplifies to 5 halves, and this is 4 over 4 equal 1, and those are my two solutions. So now you need to do problems number 2 and 8.